Hi, in this video I will review few important points that you need to keep in mind while trying to sketch the graph of a piecewise defined function. First, recall that piecewise defined function is a function which has different formulas or expressions on different pieces of domain. So domain has D1 part, D2 part, and so on. For part D1, you have expression exp1. For part D2, you have expression 2, and so on. You want to sketch these things. There are at least 3 things that you have to keep in mind. First thing is that, well, start identifying different parts of the domain, like D1, D2, and so on the x-axis. So if you have the coordinate system, Cartesian coordinate system, well, somehow identify that this piece is for D1, this piece is D2, and so on. You may have only 2 of them. Then the second thing is that sketch the curve y equal to expression 1, y equals to expression 2, and so on. But keep only for y equal to expression 1 the part which is on the D1 part. And for expression 2, you keep on the D2 part. These curves can be defined on the whole real line, but you will just keep the parts which are on the corresponding domain part. So for example, if y equal to expression 1 is like this, so y equal to expression 1, and so this is expression 2. Let me just do that. And then here, this one is for expression 1. Y is equal to expression 1. Well, we need to keep only the parts which are on the related domain. For example, here, this needs to go away, and this needs to go away, and this part also. Let me just erase. And from here on, this one needs to go away. Okay, I will come back and make those ones, and then keep everything else out there. So here, so this had whole other parts, but we will just keep the part which is on the domain 1. And this guy also had other pieces, but we will just keep the parts which is on domain 2. So this is how it will look like. And then the third point, which is somehow the convention I want you to follow, is that well, endpoints are important. Use solid bullet point, so like this, put a solid one on the end of a curve if the value of x at that point is included in the corresponding domain. In other words, if you have x bigger than equal to a or x less than equal to a, and let's say x less than equal to a is in this case is included in domain 2, you put solid bullet at the end of the curve related to expression 2 to just emphasize that yes, that point includes that value. Or here, for example, if this x is less than equal to this point here at the end, you put solid point just to emphasize that the curve includes that point on this part of the graph. Well, if it is not included, on the other hand, otherwise use empty bullet point, like the hollow one. So here this point was already included in the red one, so I need to put a hollow one there saying that, well, at this point, let's say a, the value of the function is given by this red solid point, not the empty bullet point, and so you can have solid or empty one at those ones. Okay, so those just gives you an idea what to do with these graphs. Let's do some examples and then you see everything in practice. Okay, sketch the graph of example. Sketch the graph of given functions. First one is f of x is equal to, well, x plus 1 if x is less than equal to 1. Oh, actually this is x bigger than equal to 1, and the other one is x squared if x is less than equal to 1. And the second example is the famous absolute value function. Remember that absolute value function is piecewise defined for x is bigger than equal to 0 and less than equal to 0 is negative x. Okay, for this one, well, let us just start. Identify the domain. So here, x bigger than 1, this is one piece, x less than 1. This is how you identify. And 1 is included for the bigger than 1. Okay. Then for each one of the expressions, you find the curve defined by that y equal to expression y equal to x squared. While y equal to x plus 1 is line, and we need 2 points for that. So x equal to 0 gives me y equal to 1. 0, 1 is 1 point. X equals to 2 gives me y equals to 3, and that gives 2, 3, another point. For y equal to x squared, this is the parabola, the standard one. And while 0, 0 is the vertex, it looks upward, and the points are, for example, 1, 1, and negative 1, 1. Okay, so let us just sketch these ones. For the first one, this is a line. So 0, 1, 2, 3, something there. And I sketch this piece. The whole thing goes there. But I will only keep the part which is for domain 1, because this guy here is y equal to expression 1, yes? And this is only defined on x's bigger than 1. So for all x's less than 1, I just erase that. Okay, I will repair piece. So that will go up to that point. How about the end point? Is 1 included in the domain related to x plus 1? Yes. So that means that you need to use solid bullet at the end of that piece of the curve. While we are not done, we have to use the parabola thing. The next one is 1, 1 here, then here, here. So this goes something like that. This is the whole curve y equal to x squared, but we don't need the whole curve here because this guy is only working for the function on the domain less than 1. So only that piece will work. How about the end point of this curve? Well, is x included, x equal to 1 included there? Answer is no. So you have to use a hollow bullet point. That's how you have the a sketch of the graph of the function. How about this absolute value? Well, absolute value is easier than the other one because the pieces we have are both lines. And if I start from the pieces, so this is one part of the domain, that part is another part. Y equals to x. This is line. We have 2 points. X equal to 0 will give me y equal to 0, and that means that 0, 0 is part of the curve. X equal to 1 will give me y equal to 1, and that gives us 1, 1. So the expression 1 comes here. This is the line you have there. The expression 2, this is y equal to negative x. This is the famous line. So if I plug negative 1, y is a negative 1. So y is 1. So negative 1 and y. So somewhere there, and x equal to negative 2. This gives us y equals to 2. So negative 2 and 2 is also another point. So if you do this, you get a sketch of this line. But each line works only on one piece of this domain. Y equals to x only works for x is bigger than 0, bigger than equal to 0. So I need to erase everything else from that one. Do I need to include 0 at the end of that point? Yes, because it is greater than equal to 0. So I will include the bullet there. But in this case, both of them are passing through this point. So it won't change anything if I don't make the bullet and hollow bullet. Okay, for the other branch, I will need to erase this up to that point. And while that one will need a hollow point, but as I said, these 2 points are here coincides, and doesn't matter if we put hollow or bullet on these ones. Both of them giving us the same point. So that point, which is 0, 0, is included in the curve. And that is how you sketch absolute value of x, and in general functions which are piecewise defined.